Hey guys, okay, we're going to do the video for 1-7, proving triangles congruent. So what we're doing here is we're actually going to go into the standard of formal geometric proofs. And we're going to build on the stuff that we've been doing from 1-1 all the way to now. So let's take a look at a couple things. Now, I've already mentioned vertical angles and alternate interior angles. You want to go check that out if you're not sure what I'm talking about in video 1-5. We're going to add a couple more terms to that, and that is angle bisector and midpoint of a segment. Angle bisector. An angle bisector is referring to a line that is cutting this entire angle in half. To bisect something means to cut it in half. So I have this angle here, ABD. As a result of the angle bisector, BC, which is stated as a bisector, I then have two congruent angles. So, as a result of this bisector, BC, I now have congruent angle ABC to angle DBC. Midpoint of a segment. So when I have a stated midpoint on a line, or a side, or a segment, it actually has to be a segment. It can't be a line, right? Because if it doesn't have ends, we don't know what the middle is. It has to be a stated midpoint of a segment. What happens is I have two congruent parts here. Two congruent segments as a result of that midpoint. And that is AM is congruent to BM. Now, let me make this clear. It has to state these points. You cannot assume them. You can eventually derive them, but as of right now, we're not going to see that in current proofs. We will see that in later proofs. So unless you can prove it, if it is not stated, you can't make these assumptions. So in other words, if this line, this dot is here midpoint or point M, and it does not say it is a midpoint, we cannot make that assumption. We have to go based on the evidence that we find. So now, there is kind of a secret formula to proofs, and this will become clearer in a second. First, we state the evidence they gave us. Then, from there, we try to go look for clues and find and state congruent parts. Next, we state the triangles are congruent from the congruent parts that we have, using the postulates that we have been using: side, 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 angle, side, angle, angle, side, angle, side, and hypotenuse leg. Then this is for later, but I'm going to put it on here now. If needed, state that if the triangles are congruent, so are the parts. I'll clear that up later. For right now, the proofs we're going to be doing are really going to focus on the first three steps. Okay, so let's take a look at an example. The first example here. This is a formal geometric proof. And they give us this information. From there, we're going to prove this. And I kind of like to look at these as like a formal argument, such as a court case or a police investigation. We need to have the evidence to back up this statement. Okay, so here's how we're going to go about it. First, I have to list the given, and that's what I'm going to do here. Those are the 2 points they gave us. I have to write that down. And these are given. I can either write them separately or together. In this case, I will write them together. And the next one, I'll write them separately so you can see what that looks like. Now, let's take a look at the information that gives us. So it says here AB is congruent to AD. I'm going to use my diagram to prove that, to use that information. AB is is congruent to AD. So that is congruent to that. Then it states here that C is the midpoint of BD. So C is the midpoint of BD. So that means that this and this, or BC and DC, are congruent because of a midpoint. I'm going to make a note here, and I highly recommend you do the same. I'm going to say this is due to midpoint. And I'm going to label that line 2. So I'm even going to number it for myself. So when I get to here, this is the part that I'm going to be testing on. I will have it all organized here. If remember, let me just say this ahead of time, whatever information I mark off here has to find its place to here because this is where I'm being graded. Now, I also noticed that I have a shared side here. That's also called the reflexive property. So if you want to call it reflexive, you can. But shared is fine. So this is 3. The reason why I want you to know the vocabulary so then when you see it, you know what it is. Okay, now I can state with the evidence that I have that the triangles are congruent by side, side, side. Because side BA is congruent to side DA. Side BC is congruent to side DC. And then side CA is congruent to side CA. So that was the 3 sides I was able to list. So that means I have side, side, side congruency. So I'm going to make a note of that. Okay, now to the part that really matters. I have to make sure I have that written down here. If I don't have that written down, all this work isn't worth anything. So first thing I said I was going to do, or the second thing, was to list my congruent parts. That was part of that secret formula. And the first part I'm going to list is the midpoint. So I'm going to say BC is congruent to DC. And that was because it was a midpoint. The proper way to write it is actually definition of midpoint. So I could say definition of midpoint. Next, I have the reflexive side. So that's 3. So I'm going to say AC is congruent to AC. And that is the reflexive side. I'm going to write in there parentheses shared side. For my purposes, that's actually definition of reflexive. I'm going to say shared side. For my purposes, I really don't mind you using shared side, at least for now. Okay, now I wrote this down so I could actually check these off if I want to. I'm just trying to give you some hints on how to stay organized with the information you have. Now I could write my statement. Look, I have a side here stated, a side, and a side. So now I can say that triangle ABC is congruent to triangle ADC, and that's because of side, side, side. So now that gives me, I stated all my evidence, and then I proved what I was looking to prove. Okay, next one. Okay, so this one also has a bisect of a line. Let's do it. I was kind of hoping to have one with an angle bisector in it, but I could do that in a later video. So I have angle A here. Then I have angle D. So from there, right, I also have BE bisects AD. So BE bisects AD. This is a little bit different. In this case, these lines are bisecting each other. So this is actually a segment bisector. All right. what that means is I got two lines or two segments cutting each other in half. So this is a segment bisector. I'm going to write that down for you in case you want to write it down. Segment bisector. Okay, so let's take a look what that gives me. If BE bisects AD, so if BE bisects this line, then that means that BE is being cut in half by this line. So BE is being cut in half by this line, so that means that this is congruent to that. And that is because it's bisected. I'm going to make that line 2. Then from there, I'm going to look for more. So I have an angle in the side. So that means I'm limited to side, angle, or angle, side. I have to use one of those three postulates. And looking at this, I see the vertical angles in the middle. Again, if you don't quite understand what I'm doing here, check out video 1-5, and hopefully it will help you. And this is 3. I'm going to say that's line 3, so that's vertical angles. From there, I have angle, side, or side, angle, however you want to write it. So these are out. I'm going to use 4 is going to be angle, side. Okay? So I can now prove that my triangle is congruent. All right, let's write this up. So I have to write up the given first, just like before. This time I'll break it up for you since it's a little bit shorter. Is congruent to angle D. That's given. Number 2, I'm going to say BE bisects AD. So that's what it looks like if you write it on 2 different lines. It's totally up to you. Okay, so then now line 3 is what I'm looking for next. This actually moves my line numbers over. That's 3, that's 4, that's 5. So line 3 is going to be the bisected part. So notice I have to use the information they gave me. This is how I'm doing it. In the given is the bisects. Now that kind of is going to be here. In fact, what I could do is this. I could say BC is congruent to EC. And I could just restate the given right here if I want to by just saying BE bisects AD. See that? I'm using that information to support this statement. You could have done that on the other one too. When we had the midpoint, you could have just rewritten the given there. Next, I have the vertical angles in the middle. So ACB, angle ACB. Keep in mind the vertex is in the middle. Is congruent to DCE, angle DCE. And there's the vertex in the middle there. And we said that is because of their vertical angles. I will write this formally and say definition of vertical angles. If you want to write on there because they are vertical angles, I'm okay with that. I just want you to understand that they're vertical angles. So again, when you see it, you know what vertical angles are. It's a pretty important term to know in general in math. So next, 5, I have stated here my angles and my side. This time I'm a little out of order, but that's okay. I got my angles and my sides, so that could support that. Here's an angle, there's a side. So I can now support angle, side. So I'm going to say triangle ACB is congruent to triangle DCE. And then that's angle, side. Alright guys, I hope you guys found this video helpful. Take your time with this. This takes a while to get right. But once you do, you'll appreciate it and it won't be too bad.